Okay, more practice on the remainder theorem and synthetic division. So the last two examples, I'm just going to go over one more case of synthetic division. One of them is going to come out a nice zero case, and one of them's not. All right, so we're just going to practice this remainder theorem. All right, so we've got our polynomial p of x to the fifth, fourth, third, and so I'm missing an x to the first, so I will need a placeholder in here for my x term. Right, use synthetic division in the remainder theorem to find p of negative 4. And so that means I want to divide this by x minus k, where my k is negative 4. Right, my k is negative 4. And so I'm going to go divide by my negative 4 right out. And again, remember my placeholder, 2, 7, 2, 7, negative 6, negative 9, 0. Don't forget that 0. Negative 10. Which again, this is what we're looking for. We want that remainder. Alright, drop my 2. Negative 4 times 2 gives me out negative 8. 7 and negative 8 is negative 1. Negative 4 times negative 1 comes out positive 4. Negative 6 plus 4 comes out negative 2. Negative 4 times negative 2 is a positive 8. Negative 9 plus 8 comes out negative 1. Negative 4 times negative 1 comes out positive 4. 0 plus 4 is 4. And then negative 4 times 4 comes out negative 16. So I get a negative 26 as my remainder. And so all we're looking for is that's the answer. Alright, so I know p of negative 4 is negative 26 using the remainder theorem, right? Because that's what I should get in this case. Now, you can always check your answer, and we're practicing synthetic division at the same time. So we're using the remainder theorem and practicing synthetic division at the same time. All right, you can check your results by plugging it in directly, and if you do, the answer does come out 26. So if you take negative 4, plug it into that equation exactly, all right, it will come out negative 26. And so it checks that I did my... This is actually a good way to check to see if you did your synthetic division correctly. You can check the remainder. If I plug the remainder back into my original and I get the same answer, then it's my check. Right? Negative 4 goes in. I do get negative 27. It checked, then I did my synthetic division correctly. So it's a good way to kind of check your answer. All right, let's do one more example. So I'm going to take x cubed minus 2x, 11x, 10, so 3, 2, 1, 0. So I don't have to do any placeholders. I'm dividing by x plus 2, so my k is a negative 2, right? Because I'm dividing by x minus k. In order to get the plus 2, I need to have a negative 2 in there. Write the equation, and then we'll talk about the factors and stuff in a second, which again is what we're going to be getting to in the next section. So this is sort of foreshadowing section 4.4. Right, but the division first, my negative 2 is my k. Don't need any placeholders, so just my coefficients. Alright, 1, and so negative 2, negative 3. Negative 2 times negative 3 is 6. 5, negative 2 times negative 5 comes out 10, and I get a remainder of 0. Alright, and so my q of x is 1 degree less, so it's x squared minus 3x minus 5. My remainder is 0. And so my relationship between the dividend, so this is the dividend, p of x. So x cubed minus x squared minus 11x minus 10 equals the quotient, which is x squared minus 3x minus 5, times the divisor, which was x plus 2. The remainder is 0, so I'm not going to worry about writing the remainder. And so what I've done is I've factored it, right? When we write it out using the division algorithm, it's the quotient times the divisor plus nothing, right? Because there's no remainder. And so the answer to the next question is yes. Yes, it's a factor. I factored it, right? This cube factors into x squared minus 3x minus 5 times x minus 2. These are both factors. The square function is a factor and the x plus 2 is a factor. So the answer is yes. And so what's p of negative 2? Well, you could plug it in and check it out. And it might not be a bad idea to do that, but I know it should be the remainder. It should be 0, and it is. If I plug negative 2 into this original function here, this is my original, I get out 0, and you can check that it does. Right? If I take negative 2 cubed minus negative 2 squared, 11 times negative 2 minus 10, I get 0 out. And so then the answer to the last question is, well, since I get 0 out when I plug it in, is 2 a 0 of p? Yes. Is a 0 of my p of x, my original. Right? Equals 0. That's what it means to be a 0 of it. And so that means this is where it's crossing the x-intercept. X-axis. So it's an x-intercept, right? It's 0. And that's what we're going to allude to. So this is where we're going to be, this is why we practice this synthetic division and we went over the remainder theorem, is because this last problem is what we're going to be doing in the next section, because we want to find zeros, right? The big step in mathematics is being able to locate zeros of functions. And so that's a big thing that we want to make sure we know how to do. Well, this is one way we can do it when we have very big, large, complex expressions, finding the zeros of them. All right, so that finishes up 4.3.